So, if I told you the key to unlocking unlimited nuclear fusion energy actually started in like an MSN Hotmail spam folder, you'd probably think I was totally crazy.
I mean, yeah, it sounds completely absurd on the surface.
Right. But today, for our deep dive mission, we are unpacking exactly that. We've got this 2026 evaluation from 206 Innovation Inc., and we're looking at how this paradigm-shifting framework called the CVP, or Curvature Variable Physics Confinement Layer, is basically solving fusion's biggest bottleneck.
Exactly. Which is, catastrophic plasma turbulence.
Right. So tell us about this Hotmail connection, because the origin story here is just wild.
Well, so the creator of CVP, Timothy J. Dillon, he originally built this early machine learning spam filter for Microsoft. And before his team stepped in, third-party solutions were catching like a really dismal 6% of spam.
6%? That is awful.
Yeah, basically nothing. But he pushed that capture rate up to 80%. And he did it by treating all this massive, chaotic, high-entropy data as like a structural, deterministic, geometric puzzle, not just unpredictable noise.
So he's not just filtering words, he's looking at the geometry of the chaos, basically.
Exactly. And it's a fascinating trajectory because he takes that exact same logic used to catch junk email and applies it to sub-10-second sports betting.
Oh, wow.
Yeah, and then eventually he takes it to lunar orbital mechanics. He actually used it to fix NASA's Artemis landing math.
Wait, NASA's orbital math was broken?
Well, it was being destabilized by these things called mascons. They're basically hidden underground pockets of really dense rock on the moon, and they severely warp the local gravity. Classical models treated lunar gravity as just this smooth continuum.
Which I'm guessing created some pretty massive errors.
Yeah, mathematically unbounded errors during descent.
Yeah.
But Dillon fixed it by dynamically mapping those curvature gradients. He found the hidden shape of the chaos, and he mathematically collapsed this highly unpredictable space into a deterministic outcome.
Okay, so if he could map these invisible gravity pockets on the moon by finding the hidden geometry, that totally explains why they pivoted to fusion. I mean, inside a reactor, burning plasma is the ultimate chaotic environment, right?
Oh, absolutely. It's a literal storm of magnetic turbulence that actively destroys its own containment. It's the exact same chaotic data problem, just scaled way up.
So how does CVP actually tame that storm?
So the framework introduces what's called the Dillon Operator. Historically, fusion control systems relied on single, brittle numbers, like a basic temperature reading to guess what the plasma was doing.
Like looking at one thermometer to try and understand a hurricane?
Perfect analogy, yes. But CVP throws that out entirely. It uses invariant-driven control metrics, so it actively maps the actual topological shape of the magnetic field in real time.
Okay, so instead of a single number, it maps the field and then bends the energy waves to counter the turbulence, like a variable density lens refracting light.
Precisely. By modulating these things called radial bias waveforms, the system actively shapes the electromagnetic environment. It basically damps out the instability before it can even grow.
Fighting fire with precise counterfire.
Exactly right.
I do have to push back here for a second, though, because researchers are already using deep reinforcement learning AI on fusion reactors today, right? Like the East tokamak. So if we already have advanced AI dynamically controlling the plasma, why do we even need CVP? It seems like redundant.
That is a great question. So purely data-driven AI agents are incredibly powerful, but they have a really fatal flaw. They hallucinate.
Oh, right, like language models do.
Exactly. But in a fusion reactor, if an AI hallucinates and drives the plasma into an unexplored operational state, it could literally melt the internal components of the reactor.
Which is obviously catastrophic.
Very much so. So CVP solves this by wrapping that AI in a mathematical safe manifold.
Okay, so it's less like a physical wall and more like an algorithmic tether. Like if the AI tries to push the plasma into an unknown state, the CVP math just instantly pulls the slack tight.
Yes, and it defaults back to a known safe baseline. It's called the controlled extension discipline. If physical sensors degrade or the AI goes completely out of bounds, CVP instantly triggers that downgrade protocol.
Completely eliminating the risk of a meltdown.
Exactly.
And for you listening right now, the reason this matters isn't just the cool physics, it's what it guarantees for our energy grid. Because CVP is tied to this rigorous auditing framework called TEVR, right? test, evaluation, verification, replication.
Yeah, TEVR forces every single fusion experiment to be perfectly reproducible from deterministic proof bundles.
So it slashes the immense cost of wasted, unrepeatable experiments.
Right, which rapidly accelerates the arrival of actual commercial fusion energy. We finally have a way to make fusion economically viable.
It really changes the game. But we have to mention this staggering thought from the 2026 addendum before we wrap up. The exact same structural governance mapping millimeter-scale turbulence in a lab today, well, it isn't limited to terrestrial reactors.
No, it really isn't. It's theoretically mapped for star lifting.
Which is literally extracting hydrogen from a star's outer envelope. Just mind-bending. This exact mathematical framework might be the blueprint we use to one day harvest rotational energy directly from a black hole's accretion disk. Definitely something for you to chew on until next time.